Welcome! In this series of short videos, we will give an introduction to those who have never used PowerBasic before or even considered taking up programming. Today we will look at the multiplication and division arithmetic operators in PowerBasic. One of the comments on one of our previous videos was that we had not yet covered the fundamentals of arithmetic operators within PowerBasic. So we're going to fill that gap today. We're going to look at the arithmetic operators that PowerBasic can provide for you. So in this video, there's going to be some code. What we have on screen at the moment is the PowerBasic console compiler. We're going to be using the console compiler exclusively today, as there will be some code that will not compile under the Windows compiler. What you can see on screen at the moment is our basic program. I'm going to run through some of the options that we have on our screen. The very first line is compile exe. This is instructing the compiler to compile an executable program. PowerBasic has several options here. The one we are going to be using today is the compile to an executable. The second line is dim all, dimension all. This is a command to ensure that all the variables you're going to be using are declared before use. Some programming languages allow you to use variables without declaring what type of variable it actually is. This approach is really not a good idea. If you mistype the name of a variable while you are coding, this can cause you problems later in trying to find where the error has occurred. Tools off turns off any integrated development tool code in the compile code. We won't be using any of those development tools today. There are two sets of include libraries, the Windows 32 API include and the common display.include. The Windows 32 API include comes with PowerBasic and allows you to access the API of Windows itself. The common display is purely one we've written to make life a little easier to display things on screen here. This includes a couple of functions, namely the prep output, prepare output, and the log functions. So without further ado, let's get into looking at some code. First of all, we're going to cover multiplication. If you wish to multiply two numbers together, you can quite easily do this in our code. If we wish to multiply the number 5 by the number 4, we merely have to type 5, then an asterisk, and then the number 4. In this case, the asterisk is the arithmetic operator for multiplication. The question mark at the beginning of the line is telling our program that we wish to print this out on our console. If we try running our application now, it will print out to the log the number 20, which is a result of 5 times 4. We can make this a bit more presentable on screen by putting the word answer equals before the result. This piece of text is followed by a semicolon. This is instructing the program to print out the result immediately after this string. If we run this now, it will print out answer equals 20. So multiplication can be done quite easily. However, it would be unusual in your program to hard-code two values to multiply. You would be more likely to use variables to store these values and then multiply the variables together, possibly storing the result in a third variable. So that's what we're going to do next. First of all, we're going to define 3 variables, A, B, and C. We're defining all these as long variables. A long variable is something that can hold a number between about -2 billion to +2 billion. It stores only whole numbers. The choice of variable is important depending on what kind of data you're going to be putting into the variable. In this case, our variables are whole numbers, therefore the long will do quite nicely. Next, we want to use 2 of these variables to store our values 5 and 4. The syntax of BASIC has for a very long time used the word let to allow you to set the value of a variable. Let A equals 5 and let B equal 4. The word let is not strictly speaking necessary for the program to operate. If we just typed A equals 5, it would perform exactly the same function. But traditionally in BASIC, the word let was at the beginning of these lines. So if we want to multiply both of these variables together and store the result in the variable c, we can enter the next line. This, as before, will take the value that's in variable a, multiply it by the value that's in variable b, and store the result in variable c. We can then print out the value of variable c to our console, just as we did before. So if we run our program now, it will display both exactly the same. So we've now taken two values, stored them in variables, multiplied them together, and stored the result in a third variable which we printed out to the log. As you can see, since we're storing these in variables, this information could be coming from anywhere in the program. It could be coming from the user, it could be coming from some other function within your application, or it could be coming perhaps from a database or another computer. However, as this works perfectly well, there's one thing you need to consider. If you're writing applications with single character variable names, this can be confusing in the long run. If you have to come back to support and maintain your application months or even years later, it may be difficult to follow exactly what the value of a represents. We can see it has the value 5, but we don't know what that is. Is that 5 hours, 5 days, or what? So creating variable names that give you some indication as to the function of the variable and possibly its type is always a good idea. So that's what we're going to do now. We're going to create 3 variables as we did before. You can create them all in one line as we did before, or you can create them individually. Again, each of these variables is going to be a long variable. Long days, long number of staff, and long people days. I've preceded each of these variables with LNG. This prefix is designed to indicate to anyone looking at the source code that this variable is going to be containing a long value. This way the name of the variable has 2 functions. It tells you the function of the variable, in this case we're going to be storing days in the days variable, and the fact it's going to be holding a long, which is a whole number, either positive or negative. This makes your code much more readable. And if the code has to be supported by someone other than yourself, if for example you're working within a team, this will make their job easier as well. We can now store the values in 2 of these variables, along with a suitable comment to say why we're storing it. In this case, long days is going to be equal to 5, which is a number of work days in our current week. Number of staff is going to be equal to 4, which is, in this case, the number of staff in our team. And now if we wish to determine the staff resource available in days, we can then multiply the days by the number of staff to give us the number of people days. Taking this approach makes it much easier to see what the information actually is and what we're doing with it. We can then print our people days out to the log. When you're printing to the console, you can either use the question mark or the word print. So if we run this application now, let's see what we get. And we get people days equals 20. So it's performed exactly the same function as before, the only difference being the code has been a little more readable. So now that we've stored the people days in the variable, can we do more to that variable? Let's create another variable called workday. And this is going to be equal to the length in hours of the workday. So we're setting workday equal to the number 7. And we're going to print out the number of resource hours, which is a number of people days multiplied by the workday variable. If we run that now, we will see that the resource hours we have available for development is 140 hours. We can further use this information to work out how much time a particular task might take as a percentage of all resource. Since we know the total amount of resource we have available is 140 hours, we can now work out what a percentage of an individual task will be of that number. And again, we will create a new variable for the task hours. As we did before with the prefix lng, task hours as long. And we're setting the value to be 11 hours. So for this particular task, it will take 11 hours to complete. So we'll now work out what our percentage resource is. So we'll create another variable to contain the resource hours, which is going to be 140, the value of the people days multiplied by the workday. And we're going to print off the percentage task of all resource for our individual task of 11 hours. Now, as this is a long line of text that's sliding off the edge of the screen, I'm going to fold this particular line of text so that you can actually see it. The underline character in Power Basic is an instruction to fold the line of code down to the following line. This merely makes it readable for you, the developer. So now we're going to print out to our console the words task percentage of all resource, then an equal sign, then we're going to take the number of task hours divided by the resource hours. The slash character here is the division symbol. We have this in brackets, so Power Basic will calculate the result of this first, and then having got that number, it will then multiply it by 100. So let's see, when we run that, what we'll get now. So it will give us a large number. Now, despite the fact that both of these variables are actually long variables, our calculation is actually calculating it with decimal places. This is quite normal. You may not want all these decimal places, so let's round this value to 2 decimal places. We can do this quite easily by wrapping the previous command in the word round. So the application will first calculate the result of task hours divided by resource hours, as this is in the internal brackets. It will then multiply this by 100. And then its final task is to use the round command to round this to 2 decimal places. So if we run this application now, we will see that we have a rounded up value of 7.86. So in summary, what we've seen today is the ability to use the multiplication and division arithmetic operators, operating on long numbers, either hard-coded into the application or coming within variables. And you can start to see how we can actually work out calculations using brackets. Hopefully you'll find this guide useful when writing your first applications. But that's it for today. Thank you for watching.